Good afternoon, everybody. I don't think I'm going to have to shout because the sound seems to be really good. Can you all hear me? Good. If anybody of you was in Mark's talk, just before this one, Mark said, well, I'm not going to explain Monads to you because that will take me all afternoon. Now, I only have 55 minutes, but I am going to try. So I'm not really sure it will succeed. We'll see, right? So let's delve in. And first of all, let me introduce myself. My name is Sander. I'm basically a dad of my kids. I'm a developer. I've been writing code since 35 years. So I started when I was 15, when I got my Commodore 64. But does anybody still have it? Mine still runs, actually. This is really awesome. I just can't connect it to the television anymore because there's different connectors and stuff. Anyway, so basically, I speak, I write, I program, and I'm currently working as the CTO of a company that works for the insurance industry called ANVA. Before that, I was as an independent consultant, which I am, the CTO of an insurance company, and before that, I worked for this small company called Capgemini that have like 200,000 people on board, and I was one of their Agile thought leaders. So this is my Twitter tag, this is my email address if you have any additional questions. I also have written some books, but they're in Dutch, so that doesn't really help for most of you. There's a German version of my Agile book, which is twice as thick, because of the long words, of course. There's an English version as well that has 2 additional chapters on distributed Agile, on enterprise Agile. You can be really brief about that, just don't do it. It doesn't work. And we're working on 2 new books, one on microservices and one on, it used to be called continuous delivery, but Kim, who's in the back, will do a talk on particular the subject of that book, which is now called the continuous culture. And we're starting to write on that. So, that's about it. Oh yeah, just to prove that I'm a programmer, I was in a project once for the Dutch Social Security Agency, and I was doing some JavaScript, because what they basically wanted is to mimic a COBOL application running on a 80 by 24 character screen emulation. And I said, well, it has to function exactly like it. So if you fill in some data on some page, you're not allowed to leave that page. You're not allowed to move to another tab. You're not allowed to enter a URL in a browser and enter it. You're not even allowed to close the browser. So I thought maybe I should generate some JavaScript for that, and I wrote an alert to see whether I could actually, if it closed, if the alert popped up, etc., etc. Worked. Then the project manager came up to me, and he said, can I do a demo at the client CEO? And I'm like, yeah, you probably can, but there's some untested code in there. So an hour later, I got back this screen grab, and he said, is this your code? And I said, yeah, that's my code. I do this all the time. So basically, watch out with these statements in your code, right? That's it. Okay, let's look at tries, and monads, of course. So, hey, there's a coin on stage. Wow, did anybody lose a coin? Anyway, so I'm going to talk about monads, and I'm going to explain to you one of my favorite monads, which is called the try class, which, if you already do Scala, is anybody of you program in Scala? Quite a few, actually. You already know that, right? But I'm going to explain monads to people who don't know what monads are, right? So this is going to be a basic explanation. The problem with monads is that as soon as you understand them, you cannot explain them anymore. That's a bit of a puzzle for me, actually. So I'm going to try, but I might fail as well, right? So, where are we going? So, if you look at, let's say, traditional code, so I'm not talking about a language, it doesn't matter which language this is C#, by the way, and it's also some mix of Dutch and C#, which doesn't make it more readable. If you look at traditional code like this is part of a function I found in a code base earlier this week, actually. So this is recent code, and it's full of if statements, right? Now, if you have to write unit tests for this one, it's horrible, right? Because you have to test every one of these ifs, whether they're true or false, and then the next one. So there's like 1, 2, 3 ifs, and there's even more in the rest of the code, but it doesn't fit the screen. It means you get a lot of test scenarios to do that, right? And that's horrible. Not that I don't like writing unit test code, but it's just a lot of work for code like this. And what you would actually want is code that actually is more safe as well, because any one of these functions might crash, right? For null reference exceptions or whatever you might have. It could happen. The code doesn't check. Actually, even if you look at the larger function, there's no try-catch block around it. You could say, okay, we accept that, or it might be the strategy to program it like this, but I would prefer code that is a little bit more safe and looks a bit like this. Now, if you're already familiar with monads, again, looking at maps and flat maps and recurves and stuff like that, you might say, oh, I already know this stuff. Good. So this is basically an implementation, in this case in Java, of a structure that actually has lambdas at its parameter list. So those are functions that are actually executed later on in the program. They're executed inside of the monad, by the way. So this is one of the things that you can do with monads. It makes your code, well, actually more readable as well. And you can also make it more safe. And the question is, of course, why? Well, before that, I'm going to delve into a very short and very wrong history of programming languages. Actually, I stole a little bit from a brilliant article which has the same name, which is in the references at the back of the slide deck. So, you know how old programming languages are, right? They're older than most of you. Actually, if I look through there's only a few of you who are older, for instance, than like COBOL. How old do you think COBOL is, for instance? 50 years old, you mean, or 60 years old? It's somewhere, it's around 50, right? You know what this is, by the way? This is a very nice picture. What this thing is? This is the very first bug, guys. This is where it actually comes from. And it was written down by a brilliant lady named Grace Hopper. And Grace Hopper is basically the inventor of this language called the capitalization of boilerplate-oriented language. Basically named COBOL. And COBOL, if you've never seen it, because you're much younger than I am, so you probably haven't seen COBOL, so I'll show you some COBOL. This is COBOL. It's actually quite readable, right? Except that it's also full of if statements and stuff like that, and you can actually create other functions that you can call on and stuff like that. If you look at the size of this program, and this is an actual live program, by the way, I'm here on line 28,030. That's pretty cool, right? Try to refactor this. That would be a nice assignment if somebody joins your company saying, oh, could you refactor this? It's terrible, right? So it lacks all the additional stuff that you want to have to make your code more readable and more maintainable and better testable and stuff like that. So there are no unit tests for this code, actually. You can't surprise. I looked through the code, actually, of the whole file of this 36,000 lines of code, and it has over 1,000 if statements. That's cool, right? You're not scared by that? Well, I am. So, if you look at other programming languages, like in '64, they invented BASIC. Basically as a language for people who don't know how to program, basically people who don't know how to do Fortran and COBOL, and they could do this, right? And BASIC had this very nice construction, say, oh, you can go back to something. It's called a go-to. Now, the go-to statement, if you've ever used it, was an interesting thing because it allowed you to create spaghetti code throughout procedural code. So in 1968, a famous Dutch, well, let's say, what is he? A computer scientist, Edske Dijkstra, he said, well, the go-to statement should be considered harmful. He said, the go-to statement is, as it stands, is just too primitive. It is too much of an invitation to make a mess of one's program. So then people started thinking about what should we do about this, right? Now, in 1970, remember, 1970, we started with lambdas, right? Who have used a Java programmer? Okay, just admit it, right? Only a few of you. Now, Java has these interesting things called lambda since version 8, right? Version 8. That is like 3 years old. And it was invented in 1970. There were two people who wrote a white paper on Lambda, the ultimate, and eventually they wrote something called Lambda, the ultimate kitchen utensil, which is not true, by the way, of course. And then we forgot about lambdas for quite a while, because they basically got into obscurity because Java didn't have them. So that's where we are, right? And then other languages came out that used it, and functional language came out, etc., etc. So we moved on. So let's talk about lambdas for a little bit. I'm not going to do this very, very extensively, because I do want to write some code at the end of the session just to show you the power of these monad things. So lambda expression is an anonymous function that you can use to create delegates or expression tree types. By using lambda expressions, you can write local functions that can be passed as arguments or returned as the value of function calls. So you can actually pass functions. That's the main thing about a lambda, right? You can pass them as an argument of another function. Lambda expressions are particularly helpful for writing link query expressions. This comes from the C# programming guide. few years back, of course, because C# had Lambda since, version 2, I think, which is really good. So the next thing you have to talk about is a thing called a closure. Because if you pass in a function as an argument to another function, and you allow that function to be called on later, to be executed later on, you have to pass in the parameters as well, right? Now that thing is called a closure. And without this I'm not going to explain this whole thing to you. I'm just going to show you a small example. For instance here, I've created this is TypeScript, by the way. I've created a method called closure. It's a wrong name for a function, I know that, which actually returns a function that returns a number. You got that? And it does because it actually returns the function that says n+1, which, by the way, n is the argument of the closure function. So you can actually use that, and you can say, oh, you know what, I'm going to have a function called fixed here in my code, where it actually creates, holds a function reference with a parameter 1, and you can call that later on, right? Now, as a result, it actually should always return 2, so this is the right part of the console.log. And the other one is a closure that I create all the time using the current m. So you can actually vary throughout using these different references to functions whatsoever. Okay? So that's basically how you pass. You can pass functions, and it's good to be conscious of that, is that you can pass functions as a parameter to other functions and execute them within that other function. And that's a very interesting concept, because it allows you to use those Lambda expressions to create, to do stuff that are actually handling side effects outside of the function you want to call. And that is basically what Monads do all the time. So let's move on a little bit. The next step we have to take is talk about pure functions. Now, if you've already witnessed Mark's talk earlier, he talked a lot about pure functions. Except I don't write Haskell. Does anybody of you write Haskell? I'm proud of you guys. I'm not, that doesn't matter. Okay, so if you use pure functions, I'm just going to do this briefly because Mark already did this right away. So there was a language called Haskell, which was basically created by some committee. And it's a non-strict functional language, pure non-strict functional language. And it says, well, Haskell gets some resistance, this is a fake definition, right, due to the complexity of using monads to control side effects. Water tries to appease critics by explaining that a monad is a monoid in the category of endofunctors. What's the problem? Well, first of all, I don't understand. I've never understood that sentence. I've read a whole bunch of literature about this stuff. Maybe I'm just a too simple guy for this, right? I just don't get this. It's mathematics. I'm not really good at mathematics. That's why I started computer science. Otherwise, I would have been a mathematician, but I'm not. So, what should we do about this? Well, let's explain what a pure function is for those of you who don't know what it is. A pure function is a function that you call that only works on its parameters and something comes out. There's no side effects in that function, right? So that means if I pass in two numbers, I add them up, a new number comes out, that's basically a pure function. The thing about pure functions is that it's basically how math works, right? It's, if you try to calculate the cosinus for something, it will return a result for some value of x. And as it says in the second sentence, computing it does not change x. So you do not change the parameters that come in, right? Doesn't really work. And it does not write to log files, do network requests, ask for user input, or any other stuff that is basically a side effect, right? So that's basically it. This is a nice it's a coffee grinder. Beans go in, powder comes out, that's it. Sounds like a true, good definition. Now, idempotent as the next step of this definition means that you can actually repeatedly execute it with the same result, which is basically also one of the things about pure functions. Now, let's move on a bit from this, right? Because the thing is, if I want to do side effects, let's say I want to print or I want to write to console.log, or I want whatever I want to do, put it in a database or whatever, you could consider that a side effect. And the problem is, how do you handle side effects if you only have pure functions, right? Because you cannot print from a pure function. You cannot write to a log from a pure function. You cannot write to a database or send an email or whatever you want to do. So you have to figure out ways around that. Now, the way to do that is to use monads. So now we get to the point about these monad things, right? This is where it starts. So, I'm going to try to you what it worked, what it looks like, not being a functional programmer. Okay? So So if you are a functional programmer, like some of us are, it actually means, well, you've already seen this. So let's see. Now, the thing about monads is as Douglas Crockford says, they're amazing. They're simple things, which is basically true, right? Once you got a grip of them, once you had that aha moment, it will actually change the way you write code. When I consciously started to use monads a while ago, and I had that aha moment about after 2 months after I started using them, it was okay. And I'm actually writing most of my code, basically all of my code, using monads in different languages, in different styles, and I'll show you all of them. So, but the problem with monads is understanding them is surprisingly difficult, right? That's why I'm trying to explain it to you. And most people, once they had that aha moment, seem to lose the ability to explain them to others. I still have 39 minutes, right? Which makes it a hard job, but I will do my best. Now, it feels a bit like this. Have you ever heard of this? This is one of the biases, right? As you've seen through Linda's talk yesterday, there's lots and lots of biases. This is my favorite one, actually. It's called the Dunning-Kruger effect. Once you learn something new, so you walk into something new and you try it out, and you're like, oh, I was blind and now I can see. I didn't know anything and I know everything about this topic. That's what I was when I started using monads, for instance, or when I started to, write in a different language, write in TypeScript, for instance. You think, oh, this is great, I know everything about it. And when you start to read more about it or do it more, usually it's like, this might be a little bit more complex than I thought it would be. Until you get to a point where you say, oh, I'm never going to get this, right? You've been trying monads for a while in your code, and it doesn't seem to stick to you, right? And you think, oh, I suck at this. I'm terrible. I'm a horrible person. I'm a bad programmer. You can't sleep at night, stuff like that, right? And after a while, when you get more knowledgeable, you start reading more and more, it starts to make sense. At some point in time, if you try to do monads, they will make sense, right? Not for all of you, but for most of you. And then in the end, you get there, right? Now, to me, I've been working with this stuff for quite a while, and I'm sort of like, maybe I'm sort of like in here, which is not a good time to explain it to you, I guess, but let me try. So, let's do the complicated stuff first, which makes you think, oh, this is not for me, right? Basically, monads come out of category theory. Now, as I said, I'm not a mathematician, so I don't know how to read this, actually. If you are a mathematician, please help me out after the talk, right? Basically, it's a functor, and it has 2 natural transformations. Now, how do you explain that, right? I'm going to try to explain it in human language. So, there's actually a couple of things you need to know about these monad things. And one of them is that they're basically boxes. So this is the very basic explanation I can give you, right? So I don't know shit about it, and this is it. You can put something that you have inside of a box. And then you can let the box handle the side effect. So the thing inside of the box stays pure. Now what's the next thing? Well, the next thing is you have to be able to do some sort of transformation on the thing inside of the box. So first you have an orange bowl, and you apply a function to it, and then it becomes a green bowl. Right? But it's still inside of a box. And then you can apply another function, it will become a blue ball. And eventually, at some point in time, you think, oh, you know what, now I want to have the value that is inside of the box. And so you need a function on your monad, so the monad is the box, right, to get the value out again. And instead of an orange one, we now have a blue one, and the box has handled the side effects throughout these bind functions. That's it. This is all there is to know about monads, except for, well, you have some more stuff. A little bit, by the way. So usually monads have like functions to do stuff. Basically, most of them have a map function. Now, what a map function does is, if you have an orange bowl, and you have a function to transform the orange bowl to a green bowl, you can put that inside as the parameter to the map function, and the return value of that is the green ball in the box, right? Now, there's a second variation, because the function that you will try to put into the map function could also already return something inside of a box. Now, if you would apply the map function to that, you would have the green ball inside of the box inside of the other box. which is something you don't want. So there's a second variation to this. And it's basically, if you have a function as a parameter that has an orange ball and transforms to a green ball inside of a box, which could happen, you don't need to return the double box with the green ball in it, but just the green ball in the box. This is it. This is literally it. This is all you need to know to build your own monads. And the funny thing is, you've already seen them, right? I'm going to show you a little monad that is actually in a lot of programming languages already present. Let me show you a simple problem that you could have. Let's say you have a class called person that has two properties, one of which is the town he lives in, or she, and this is C#, by the way, and if you have a town, it could be in a country, and the country has a name. Really simple stuff, right? And I know you're already thinking, since C#6, we have the Elvis operator to handle this. Yes, you do. But the problem is, if you write code to it normally, without having the Elvis parameter, you probably would do it like this. And this is not even right, because if you look at this code, there's an error in the code as well. But it checks for nulls continuously. Except for when I get the name out of the country, right? Because it could still crash. On the last line that says name is CNAME, and then that would crash if the name would be null. Now the problem with that is that there is a very simple mistake that was made a long time ago by this really fine gentleman called Tony Hoare, Sir Tony Hoare, by the way. And he said, well, in '65, so that's a long time ago, I was designing the first comprehensive type system for references in an object-oriented language called Agile. And my goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference. That's where it all came from, right? It's this gentleman here. And he says simply because it was too easy to implement. It is, and it's very hard to get rid of. Really, really hard to get rid of. And he said, I basically call that my billion-dollar mistake. Now, I've made a few mistakes myself in programming, but not one that is this expensive. And it's probably even more, because there's so much time spent by programmers just testing for nulls, which is obvious stuff, basically, and it's horrible, and we all make the same mistakes. Even when I wrote this really stupid example here, it still contains an error, right? So it's very hard to get rid of these. Now, what you could do is you could create a monad. Let's call it maybe. And now what this monad does, so it has these functions, right? You can put something inside of a box. So this is, you put T, this is C# again. You can put a T, any object of type T, inside of the box, and you have the box, which is called the maybe, with the value inside of it. The next thing you want to do is you want to have a map function that actually says, I can pass a function as a parameter, which the T coming in and the U coming out. But what we'll do is, we'll put it inside of a box. So we'll invoke the function, and then we'll put it inside of the box again. By the way, this doesn't deal with try-catch blocks and exceptions and stuff, but it's really nice. So if the value inside of the box was already null, we're going to return a maybe none. So I didn't put the maybe none on here because it didn't fit the slides, although the slide's pretty big, right? And so basically that's an empty version of a maybe. And there's also a second map. It was a flat map, but the function overloading in C# allowed me to do this. That says, if I have a function of T that actually passes back a U inside of a box, you don't need to put it inside of the box. You can just invoke it. Right? You'll get this? Even though you might not read C#, this is plain to get, right? That basically allows you, all these arrows, that basically allows you to write your code like this. Now this is different, right? This doesn't have any null checks. Now I know C# has the Elvis operator, so you could write this out in one single line. But other than that, what we do is, a person comes in, we put it inside of the box, and then we have sort of a transformation that says, I need the town where this person lives in. With that town, the town is the value inside of the box with the next line of code that says, get me the country, and from there we can get the name. And if it's empty, we'll just do an empty string. So this handles your null references. So the side effect that this maybe class is handling is checking for nulls, right? Which is pretty nice. But this is an easy one, right? So you can do more complex stuff. Now, the interesting thing is, I was reading up on my literature, and literally, so what today? Is it the 16th or the 17th? well, somewhat. This is fairly recent stuff, right? The C# team now realizes, after having been there for 20 years, no, not 20 years. I was at the European introduction of C# in 2001, I think. So it's like 16 years old. And now they said, you know what? Today we released a prototype of C# feature called nullable reference types. They're actually going to change the language. This is, if you're a C# programmer, this is a very nice article to read, because they're actually going to deal with null references in a much better way than they did before. Which means you don't need the maybe class, you don't need the Elvis operator anymore. This is a very interesting blog to read. Just read it. Okay, so what's the next step? Now, if you look at Monads, you're probably already familiar with them without you even realizing that this stuff is Monads. So the select many, all the linked stuff in C# is basically all Monads. If you look at the task class for handling asynchronous stuff, it's already a monad. What does it do? It handles the side effect of being asynchronous. That's what it does, right? So you already know this stuff, and you already use it. The thing is, you can use it even more when you want to. Now, another example. Let's look at different languages. So this is basically JavaScript. Who of you is a JavaScript programmer? I thought everybody would write JavaScript these days. I made a very terrible joke about it a while ago at a conference. I got nearly kicked off the stage, so I won't make that joke again. But if you... No. Well, you can kick me off stage anyway. In JavaScript, there's a class called promise. Have you used the promise class? You probably have, right? So what it does the same as the task classes, more or less. You can put in a function that it will handle asynchronously, like doing a request to some sort of component or web service or whatever you want to do, and it will check whether that call actually gets fulfilled or rejected. If it gets fulfilled, you can handle on the value that comes out of it. And you could do that again using a promise, because a promise will always return another promise. So the value stays inside of the box, and you can do various transformations on that. But on the other hand, if it gets rejected, then you have to look at the catch clause. So you can do something when it is rejected, and, well, I don't know, do an error message on the screen or whatever you do. And if you use it, your code might look a bit like this. So this is TypeScript. This is our own code. So what it does, it validates the account object, and it validates this, which is basically a use case in code. And then it goes out to the repository, and to say, you're going to have to save this account. Now, the repository also uses a promise, by the way. It goes into a service class, and the service class talks to everything which is outside of this particular web application, and it comes back eventually, or it doesn't, or it passes back an error, or whatever it does. And you can handle that, right? So if that call is okay, if it's fulfilled, then we say, okay, this .account is set to the account object that comes back out of the previous then. So again, it's actually doing transformations on the thing that is inside of the promise. So this is very much a monad. Now, then we say, oh, you know what, if it's okay, then we say, this is Dutch, by the way, so you won't be able to read it. It says basically your account with this title has been stored. Good. But if in any of these clauses something gets rejected, what will happen is this code will actually skip all the thens that are underneath that particular clause that crashed, and it will move to the catch clause. Well, actually, it does passes through all of these thens, of course, but it doesn't do anything based on the fact that it's already rejected. And this is typical how monads can work. So let's say that the second clause crashes. The repository save returns an error in some format or whatever. Then it does go through all of these calls that are underneath, but it doesn't execute all these functions. It's just moving towards, whenever there's a catch clause, it will actually execute the code that is in there. And now it will say, you just have to put the error on the screen, and that's it. So this is a very elegant way, I think, to be able to deal with any type of exception or error in this case that comes along, and deal with it without having to write all these try-catch blocks and if-then-else and whatever you might have, right? So it's actually, it's clean, it's nice-looking code, it's easily readable, stuff like that. So there's the promise class. I'm going to show you another one that we built quite recently, because I don't like all these switch cases and stuff like that. So I thought, you know what, I could actually write a monad to do that. So it took me about an hour or two to do that. And if you look at the code, it's actually pretty simple. So executing a case statement means there's an input coming in, which you check for the value of. And if any value matches any of your statements, you'll execute a different part of your code. Pretty simple stuff, actually. So what I did, I created an off method that actually says, put the value, which is an any, this is TypeScript, right? You can put it inside of the case, which is a box. So case is a box, right? That's pretty cool. And you just put it inside. And then I have this thing called the with function that says, please check if this is true, based on the input that you put in, the value there. And if it becomes true, just execute the second method, and you're done. And then the thing is, if you put them all after each other, you don't want to have that if the first one already matches the criterion. You don't want to have the other ones to also evaluate. So I put in a Boolean. It's not my optimal solution, but it works. We've heard that before, I guess. But so basically, it says if we're not already validated, then execute the predicate, which returns a Boolean. And if that is true, then set the value inside of the box to whatever function you pass in, or the result of that function, actually. And then you say, oh, evaluated is true, and then you're done. Now, if you look at the code that comes out of this, it looks more elegant than if you look at the monad, right? So this is a simple monad executing a switch case statement. It says, when there's an input, and this is actual code, by the way, when there's an input, so that's the I for all of these with, if it's an instance of error, do that. If it's an instance of error response, do that. If it's an instance of results, do that. And if it's a string, handle it as a string. And else, do this. Now, let's say the first one actually is true. So it is an instance of error. That basically means it is evaluated. So the next calls to with don't get executed. Again, that's a very simple way of going through a series of function calls that are not executed if something goes off. Also, what I didn't do, what I should have done, by the way, is also put in that take care of when any of these methods, when I invoked them, when I called them, would return an error, right? So I didn't put in any error handling in the box, but that would be additional functionality too. So that's really nice, right? So, are you still with me? Well, you're still here anyway. It seems that I guess they locked up the doors, probably something like that, right? So basically, the rest of the talk will be, which is like 22. Wow, I have still 22 minutes. What am I to do? I could write some code later on. I'll do that. So I'm going to talk about the try class, which is probably my favorite monad, and it comes out of Scala. And what it actually does, it handles a lot of stuff for you that you don't want to handle. Lots of the side effects in your code, like try-catch blocks. Do you love writing try-catch blocks? Does anybody like writing try-catch blocks? Yeah, sure. Is there anybody who never forgets to add try-catch blocks to its code? I always forget it because I'm lazy, right? Or I just forget. Even if in simple things like get the name of a country, that actually could throw an exception. You don't always know that, right? So you would have to write try-catch blocks around everything in your code. I have colleagues who actually do that. It's very verbose code. It's really long. And the thing we're now moving to will actually help you get rid of that. So Gerald Weinberg says, the if-then-else construct for flow of control is simple in some senses and certainly superior to unrestricted go-to logic. This is an old quote, right? 1975. The indefinite replication of this structure leads to undesirable program constructs. Basically, if you think back about the COBOL code that I showed earlier, with all these nested ifs, that's very, very hard to test. With my previous client, there was a Java programmer who did really traditional style Java programming. Like, I have an if, within the if is a for loop, and then there's an if, and another for loop, and an if, and an if, and a for loop, etc., etc. That code is just basically impossible to test. Now, if there's anything I don't like, it's untestable code. And COBOL. No, just untestable code is enough, right? That's basically the same. Anyway, so we could try to get rid of it. Now, then, one of my colleagues found a class in Scala, and he said, you know what we'll do? We'll create the same thing in Java. And in the meantime, we've done the same with TypeScript and with C#. So this construct you can use everywhere if you have lambdas to your possibilities, right? So this is the try class in Scala. I'm not going to explain this one to you. I'm going to try to explain how it works. Now, the try class is a monad, so it's a box. And you can put something inside of the box, and then you can actually do these mappings, right? You can pass a function as a parameter, and if it executes okay, then you move on. If it doesn't, you don't move on. So this is a thing that actually basically handles your try-catch blocks. What happens is, there's an abstract class called try, and there's two concrete classes called success and failure. So every time we pass in a method, we invoke the method. If that throws an exception, because this handles the side effect this thing handles is exceptions, then we'll return a failure, which is basically still an instance of a subclass of try. And if it executes, if it doesn't break, if it doesn't crashes, we'll return a success. Now, since these are subclasses of try, they can still do all the functionality that try does as well. So let me show you the code for that. This is the abstract class try, and the abstract class try, it has, I'm just going to look at the map and flat map and the recover function. So just assume that there's a function that you can put something in the box, and there's a function that you can pull something out of the box again in the end. But these are the functions that actually make it interesting. So there's a map and a flat map. This is Java, by the way, and it has a checked exception. There's a function coming in that actually returns something of type U. So you transform the T into U if it works well, still inside of the box. Now, also there's a flat map, of course, and in this case, Java doesn't actually see the difference, so I had to name it differently. If there is a function that actually returns a U already in a box, in a try box. So most of my code has this, by the way. Now, if something goes off, so if there's an exception somewhere along the line in the execution of the try class, we need to be able to recover from that. You don't always do it, because what will happen is, if it comes into failure mode and you get the value out, it will throw the exception anyway. So you don't always need to do that, but if you want to recover from some sort of failure, there's these recover functions. Now there's two subclasses, as I said. So the success class, what it actually does, it implements the map and the flat map. As an example, I'll show you the flat map. So basically what it does, a function passes in that has a t as its parameter, so that's the value that's inside of the box. We'll use it as the parameter, and in this case, the try u comes out. So I'll just apply the method to the value within a try-catch block. So this try-catch block is inside of the box, not inside of the ball that's inside of the box, right? So the ball that's inside of the box doesn't have to handle the try-catch blocks. So I can actually transform it here from a T to a U inside of a box and then return it. If there's an exception thrown, we'll return a failure. That means it will return an instance of failure, but instead of the value that's inside of it, it now has the throwable T, so the exception inside of it. The failure class just works the other way around, because you see, the recover, if I call the recover and I'm still a success, nothing happens, I just return. And the failure class works the other way around, so it looks like this. So here, the flat map doesn't do anything. It just returns a new try, again, with the current exception inside of it. But if I call a recover, then I'm going to try to execute the recovery method, to apply it here on the exception that is inside of it. And if that works, then I will have a T again at the end. If it doesn't work, again, I'll throw a failure. Now you might think, how on earth am I going to use this stuff? Now I'll show you some code, right? Again, this is Java. And here you see the full thing in function. So this is actually handling a post inside of some web service that we have. And we put it inside of the box by doing try off. Now, if this doesn't break, that means it will return a success, an instance of success, which is still a try, right? So the map here is then executed on I don't know how to use this pointer, otherwise I'm not long enough to actually touch that code, so I'm going to use this code, right? Because I got this new pointer, and I'm not really sure how it works, I'm not going to try. Basically what happens is the input here is the I here, and we'll try to create an instance of node, which is just a domain object, actually. If that works, that could also crash, by the way. If that works, we'll try to insert it into, we'll pass it on to the use case called insert node, just handle it. And if it handles it and it puts it inside of the Mongo database that we have, then we're still okay. And here I still have a success, but now with a node inside of it. And in that case, what will happen is return a created statement is saying that, oh, here's the object you created, and pass in the URL, and I'm done, right? So if it works, I'll end here. If I'm a success still here, and I get to the recover, as you saw on the previous slide, nothing happens. Again, the next recover, nothing happens, and then I do a get. That means I get the value outside of the box, from the box, and the value that's inside of it is this one, actually. It's the response created, so it's a response object. So if everything's okay, we'll return a response object. If anything somewhere goes off, we might handle it in different ways. For instance, if I validate, I'll probably do some validation somewhere, and if there's a validation exception thrown, I'll return a bad request. If not, we've made a mistake, and I'll return an internal server error. Basically, so this is overloading that one, actually. So the failure class knows how to handle this, and it doesn't handle anything here. So if creating the node already breaks, then that means I'm a failure here. Failures do nothing with the flat map, failures do nothing with the map. Hey, there's a recover. Is the exception that I'm now holding inside of the box a validation exception? That happens. If not, I'll do this one. That's basically it. So at the end, I still have a response. So if I get it, I still can return a response object. Now this is very, very clean code. This handles all of my exception calls, right? And that is really, really cool stuff. When I first started using this a couple of years ago, I was like, what is this, right? It took me a while before I got this aha moment. But ever since, most of my code actually looks like this. Every function I write in Java, or in TypeScript for that matter, but in TypeScript I use the promise class more, I start with a return. I say, okay, what is it I want to return? And then I start setting up, okay, let's put something inside of the box. And then what do we want to do? What are the steps that we want to execute during this procedure, during this function? And then what do we want to return? And it becomes very, very clear on how to program. So actually, I'm not saying you have to do this, but in the end, at the end of the talk, it would be cool if you could start trying this stuff out. Because it really makes your code look very, very different. It's much more robust, much more stable. I'm not going to use the word reusable anymore because that's not fashionable, right? So there's I created a C# version of this thing as well. There's a number of implementations of that. Just look into GitHub. There's a whole bunch of this stuff out there. And there's a TypeScript version as well. Oh, this is the test for the C# version. I'll just skip it. A colleague of mine, René, created a try class in TypeScript as well, and it works really, really well. I'll show you that in a small demo if I have some time. And it's basically the same stuff, right? And you can use it in most programming language, basically in any programming language that uses function as a first-level citizen. So that's basically interesting stuff. And I like it a lot, I can tell you. So let me show you a bit of code. This is always the scary part. When I first started doing talks at conferences, my mentor then said, never do coding live on stage. And I still remember that, although I didn't listen. So I'm going to try this out. So I'm going to do, I hope this actually shows up. Is it here? Can you see this is WebStorm, right? So I'm writing TypeScript. Let me show you what I did. I created a person class. So there's the person class. It just has a name. And I created a class foo, because every code example needs a class that is called foo, right? And I can create an instance of foo using a Boolean. I know, this is stupid code, but it's just to illustrate stuff, right? And if the Boolean is false, then I'll throw an error. Basically, that means I can create a situation that makes my code crash. That's what I want to have. If it doesn't, then I can return a person with no name, a person with no name, or a person with a name. And I'll show you what I'll do with that in a second. So I'm going to try to write some code to this. La-di-da-di-da-di-da. So I created a test class. I'm going to create a test. Let's see, test. Do something. I'm actually making this up as we go along, right? So, let result is, so I'm going to put something inside of the box. So this is the box, basically. So in this case, I'll need a method that actually says, what will do? New, oh, my cursor moved. New foo. Now I need to pass a Boolean, so I'm going to say act normal, right? So it doesn't crash. That's a Boolean I created up there, right? So this passes back a result. Now the thing with the try class is that you can usually ask it whether doing something was successful. So I can actually create an assert now, assert equal, yada yada yada, result dot what? Is success. Cool stuff, right? It needs to be true. Does that work? Wow. So this is my first test, right? I'm just going to put something valid inside of the box. Cool? Let's run it. I hope it works. That would be exciting, right? Ooh. And that on a Thursday afternoon. So, all right, it passes. Cool stuff, right? I just put something inside of the box. Now, what can I do with it? Let's see what I can do with it. So now I have a box. So what can I do with the box? I can do a map. So the thing that's now inside the box is a foo, so I'll name it f. So f dot what? F dot person with a name. Okay, so now what I did is I got the person object from the foo class. Does it still run? Let's see. So, oh, it still runs. Well, this basically is a function, because it returns, it doesn't look like a function, but that's TypeScript, right? If you want, I could create a function from this, right? So it's a getter. Now we have a function. That's your fault if it doesn't work. It's out of my hands. Oh, it still works. Cool. So it is a function, right? So what else can we do? Let's get, from this person, let's get his name, which is a property. So yes, it's a function. I can create a function of it. Would it still work? A person with a name. That probably would work. Wow, still works. But a person without a name, I don't know what I called it. Person with no name. So that means the name property isn't filled, right? So it's null. So what do you think now happens? Will it pass or succeed? I didn't do anything, right? So it succeeds. Because I got the name out of it. The name is null, but I didn't call a function on the name, so nothing happens. There's no null ref exceptions, I guess. I hope. Otherwise, I will be really stupid to show this, right? Oh, it still passes. Now, what's the next step? Let's see if I can actually... I'll do a 2 lowercase. That means, now, the name is null, and if I do a 2 lowercase on that, what will happen? Yeah, it's going to throw an error, right? But since this thing is executed inside of the map, and the map handles the error, what will happen is it doesn't crash. So if I wouldn't do this in a map, my code would crash, right? But because it's in the map, it doesn't crash, I hope. But it will fail, I hope. See? You know how scary it is to program in front of like 400 people or whatever you are? So I expected this to crash, right? Because the thing is, I had in the assert equal, I said result is success is true, which it isn't, right? Because in the end, what I will have back is a failure. Now, a failure is never a success. So I could actually say, you know what, this is false. Right. Pretty cool stuff, right? So this is just a basic example of what you could do with this stuff. Now, what happens is, if you look at code like this, I much rather test for whether something is a success or a failure instead of having to test for all these exceptions or errors if you do JavaScript, right? So it makes it much easier to write testable code and to test your code. Now that is a big advantage, I would say, to writing the code. So, should I show more? Well, I should do a recover, right? So now it fails. So what do I want to do? So basically, I want to say recover. So what do I want to recover with? There's an exception probably. I go from the exception to, I don't know, a string or something. Too bad. Now that is cool code, right? So instead of this, I'm now going to check, oh wait, I'm going to get the value out of there. Value, right? Did I put the value or get? What's the function I used for that? Let's see. Oh, I'm now returning a string, so it's already okay. Right. So what I now can do is this. Instead of saying, are you a success, which it isn't, oh, it is now because I recovered, I could actually check whether the string matches the string I have in my recover. So basically, if this would be successful, which I hope, and you can never be sure, right, because it's still code, that means that, okay, this function in the map will actually return an error, but I'm recovering from that by returning a string. Cool stuff. So let's see. Oh, let's see what happens. Oh, crap. I just created an empty line, which you probably don't do in JavaScript. Right. So, hey. Cool stuff, right? So, this is the cool stuff. So this was my short code demo. Really scary. I'm sweating a lot. So, I probably need a shower before we go out drinking beer. So, some last thoughts. In retrospective, basically, when I started doing Monads consciously, because most of you will use them all the time without you knowing it. I saw a talk earlier that was by Camille that was full of Monads, actually. So it's really good stuff. And the thing is, if you use these Monads, your code can be more robust. Because it's not just this single function that I'm using this in, but it's also the functions that, so if you look at the code that I had in my post, I can actually put it back on screen. Oh, the other screen. Where is it? Here. So it's not just that I'm using it here in my resource class, it's also the insert node.insert actually also returns a try. And the code that's underneath that also returns a try. So we chain it along the way throughout the code. Now, you get a lot less code, and also the code is very, very robust. I shouldn't be moving along through my slides anyway. So, and it can help you move away the side effects and make purer code. So it's not pure code like in a functional language or in Haskell or whatever. It's purer code. And it will help you actually to get rid of side effects such as, I don't know, if then else, try catch blocks, anything. We can do anything with these monads. And the fun thing is, well, I just show you with the little bowls and the boxes and stuff like that. It's not very hard to create one. So figure out logging, for instance. If you would do a monad to do logging outside of your classes that do the actual work, that would be really, really cool. And by creating this slightly more functional style in, let's say, languages like C# or TypeScript or Java for that matter, or maybe Kotlin. You want to do Kotlin, right, Dominique? Yeah, I know. It helps a lot, right? So that's basically the conclusion to this talk. I'm not sure where we are in time yet. When do I need it to stop?
We've got 3 minutes.
3 minutes? Yeah, if I close now, then you're earlier at the coffee than the other people, right? Oh, there's some questions. So I'll wrap it up first, right? So this is, so yes, you should allow your team to learn all the time. Take some time, this, right? So the Dunning-Kruger effect is real on this. I can tell you for sure. I've been through it. And also, well, by the way, never forget to have fun. That sort of hooks to the question on the top there. I'll leave you with the references. They're in the slide deck, so I have to upload the slide deck to the conference website. Anyway, so here's my credentials. If you have any more questions on whatever, except for my PIN code, then this is my email address, my Twitter account, etc., etc. So what was the joke about JavaScript? I shouldn't do this. No, the second question. Why did we need to replace the switch case with a monad in the first place? Well, you don't, right? But the thing is, if you have a traditional switch case, what happens if any of the functions that you have in there, or any of the checks, whether this is true and that is true, would actually maybe return an error or crash for that matter, whatever, right? You could handle that in the monad in a single clause, just by executing the predicate and executing the function within a try-catch block. And that's the only try-catch block you then need, right? Instead of having it in every clause in your switch. Notice your t-shirt is promoting build stuff at North Korea. It's actually a thing. It's next week. This is cool, right? It's a collector's item. Now, if you look at the website, it is actually next week. But, of course, this was an April's Fool's joke, right? So no, it's not actually a thing, unless you think it's a thing. Right. Are the Netherlands going to the Football World Cup next year? We might, but we figured out that we had to eliminate a couple of countries. If there will be revolts in countries like Sweden or Morocco, then it's probably due to secret agents from the Dutch intelligence service that actually try to get them out of the championships and move us in. But no, fortunately not. So, was it hard to convince your colleagues to use Monads? Yes, it was. Because it takes a while before you see the first. So the Dunning-Kruger effect on this is really, really real. It takes a while before you get the value of this stuff. But most of the people I've worked with since I tried doing this actually write most of their codes in this style. Right, Dominique? Bram? Yeah, Bram says yes. So it's, he says yes, it's true, right? How if then else is a side effect? Well, it's a side effect if you have to test your code. Then there's different paths that you have to test. Well, you have to do that anyway, by the way, but it can be more compact, by the way. So, yes, if then else's will. Actually, if you look at the code that comes out of this, if you do this, I didn't see, there are no more if then else code. I never, hardly ever write if then else statements anymore. Personally, I like that a lot. Does it remove them all away from your code? No, it doesn't, because they're still there, they're just encapsulated. Any more questions? Oh, wait, wow. Can you give an example of a monad in SQL? No, because I haven't seen a relational database in like, I don't know what, 6 years or something. So they're probably there. Does anybody know an example? In SQL, right? No, well, the answer to the question is no, right? What? No, you can't pass functions, at least not that I know of, but maybe there's databases that actually...
SQL is Turing complete, you can do anything.
Anything in SQL, right? Just like COBOL. Yeah, so you could probably, no, you cannot pass a function, right, in a database to another function. Monads look great thing to use, or did I skip one? Still, the joke about JavaScript is still there. Why isn't it gone? Oh, it's been voted on? Wow, cool. So, well, it's actually so I was at a conference in June. I'm not going to tell the joke, though, but I'll tell you the story. So I was at a conference in June in London, and I was talking in front of a big room, and I made jokes about a lot of language, like Swedish, and Dutch, and German, and Java, COBOL, C#. I usually do that, and JavaScript as well, but somehow people in the audience got offended by the joke on JavaScript, which wasn't any worse than the joke about Java. It's just that there were 700 JavaScript developers in the room, so I didn't count on that. And so there's no video of it either, so the conference started was really bad, and they didn't put a video up, so I'm not going to tell you. So you imply that Monads, oh, cool, thanks. Who does that? That's a secret, right? Cool stuff. You imply that Monad code is easy to read. I'm scared of it. Sorry?
That's a statement, not a question.
Oh, yeah, it's not a question, right? I think it's easy to read, but I love reading all these functions just in a row. It makes my code really compact. You have to get used to it. It takes a while to get used to this, especially...
It's probably easier to comprehend with JavaScript, right? Because there's lots of...
It's the same. We use it in C#. We use it in Java as well. A lot of the code I showed you was in Java. So it makes it really, really readable, I think. So there's one more. Monads look really great thing to use. Can it happen that it is a new legacy? Well, every code you write is new legacy, right? Especially in the language that I wasn't joking about. So anyway, this is probably the last question, right? Thank you for being here and indulging me in not making questions about JavaScript. I hope you enjoyed the rest of the conference.